So let's say we have an exponential equation where we can't get the bases the same. So say you have something like b to the x equals c to the y. You're allowed to apply the logarithmic function to both sides of the equation. So you could say log, any base, n, b to the x equals log, you've got to use the same base, so log base n of c to the y. And then we can use logarithm properties to solve the equation. Okay, so that's what we're going to do. We're going to show you an example here. Now, you could use any base. A lot of times we'll use either a common log or a natural log, because then we can put things in our calculator and get a decimal approximation. I'm going to try to remember to use natural log. There's some advantages to doing that we'll see later on when we have equations with e in it. Sometimes it's more useful to use a common log if you have a base 10, but I'm going to kind of stick with my natural log just for consistency. Okay, so here we have an equation. When you get one, an exponential equation, the first thing I would do, I would look to see if I can get the bases the same. But one's a 5 and the other's a 4, so that's not going to happen. All right, so I'm going to apply the logarithm function to both sides, and I'm going to do a natural log. So it's going to look like natural log of 5 to the x plus 2 equals natural log of 4 to the x. It's just like if you were to square both sides of the equation, or you were going to take the square root of both sides of an equation. The logarithm is a function, and so you're applying the function to both sides. Okay, well, now what do? We're going to use the power rule, so we're going to bring the exponents down in front. So I have x plus 2, notice that I put in parentheses, natural log 5. And then on the other side, I'm going to have x, natural log 4. Now, just a comment about natural log 5. That is a number. It is not a variable. It is some number you can put in your calculator and get a decimal approximation. Same with the natural log of 4. It's just a number. Okay, so remember that, all right? All right, we're going to distribute here that number that I was talking about. X natural log 5 plus 2 natural log 5 equals x natural log 4. Now, if you're saying, well, why are we distributing? What's the point of that? Well, we're trying to solve for x, right? So we need to get terms that have x on one side and everything that doesn't have x on the other side. So I'm going to put my x terms on the left. I'm going to put the term that does not have x on the right. Now, if you were thinking, oh, I wanted to put the x terms on the right, you could do that. I just chose to do it this way. Okay, so now I can factor out an x, and I have the natural log of 5 minus the natural log of 4 equals negative 2 natural log 5. Now, all of this, natural log 5 minus natural log 4, it's just a number. So we're going to divide by that number on both sides. Okay. Scroll a little bit. So you get x equals negative 2 natural log 5 over natural log 5 minus natural log 4. I would probably clean it up a little bit. Think about that negative sign in the numerator, take it through the denominator, and write it as 2 natural log 5 over natural log 4 minus natural log 5. It's a little bit cleaner. On an exam, I don't really care which way you have it, but probably most textbooks are going to put it that way. It's just a little more simplified. So I would leave it that way, the way I have it with the box around it. Your book doesn't do it that way. They use some more of our properties. So they put the exponent back up and make that the natural log of 5 squared over, and then they're going to combine that to be natural log of 4 over 5. And then that would be natural log of 25 over the natural log of 4 over 5. Okay, so that would be an okay answer. Your book doesn't even do it that way, though. They use the other form that I had. So they go natural log 5 to the negative 2, which we can deal with that. Natural log of 5 over 4. Now you're probably going, how many answers do you want? Natural log of 1 over 25 over natural log of 5 over 4. I think your book has it this way. I don't think that's the nicest way. I think this one's nicer if you're going to put it back together. But I probably would leave it that way in all honesty. Now there's advantages. It depends on what you're doing and stuff. Remember, this is just a number. All three of them are just a number. You could plug each one of them into your calculator and it would give you the same number for all of them. So if you did want a decimal approximation, it might be, which one would be easiest to put in the calculator. Probably that one's the easiest to put in the calculator. I don't know. These, by the way, are exact answers. As soon as you put it in a calculator, it won't be exact. It'll be a decimal approximation. Okay? I think that's all I'm going to say on that one. Now, if you're a little concerned about, well, which answer does my teacher want? I don't care. I'm okay with any of the three. In WebAssign, it shouldn't care either. So I can't guarantee that, but it shouldn't matter. The other thing is they may have directions in WebAssign that say specifically, have one logarithm in the numerator and one logarithm in the denominator. Okay, so go by the directions. Otherwise, it shouldn't matter.